is additional data caches. I walked into shops that have literally dozens of separate cachelets which have been set aside for purposes of putting this high-volume table, this set of indexes, that set of logs. And caches are frequently over-segmented. I really don't like the over-segmentation or over-partitioning of the caches into separate caches. And the reason for that is if you're going to over-partition the caches, what happens if 6 of the caches are idle and the other one is really busy? You're simply not going to make use of all the space and memory you've got. The primary reasons for creating caches, or multiple caches, is tended to be spin lock contention. A spin lock is a very fast, non-transactional lock, which is used to avoid contention in multiprocessing environments. If 8 processors, they all want the same physical page, who gets it? Well, there's going to be whoever gets the spin lock. So what are we going to do with the spin lock? The idea behind the spin lock is the spin lock controls a latch. The latch is the entry into the cache, into the I/O buffer, into the you name it. So what we're going to do with that is get in there via the spin lock. Now, the way the spin locks work, you want to make sure Sybase doesn't got any bugs in the spin locks, because that will happen on occasion. We were at a shop in the last, it was a little over 2.5 months ago. I was at a shop. We implemented the monitoring tables, and we managed to find a bug that nobody had stumbled on before. We were querying the monitoring table, and the monitoring table itself put a spin lock on an internal resource. Now, what the spin lock does is, a regular lock, if I say, give me this page, and the server says it's not available, what happens? We go into a wait queue. Well, from the wait queue, we sit there, and we will sit in the wait queue, and when the I/O completes or the lock becomes available, we'll go there and we'll have the access into the wait queue. With spin lock, the spin lock doesn't sit in the queue. The spin lock says, are we there yet? Are we there yet? Are we there yet? Like a teenager in a car on a long trip, or a 5-year-old on a car on a long trip. Kind of the same, right? So to avoid that, now the spin locks get the results back very quickly, but we want to make sure that we're able to get through. Now, if we have 20 processors and we have spin lock contention getting into the caches, well, getting into the caches is a good thing. We want to be able to get to the point where we're saying, let's get this information, get the page out of cache faster. We want, that's the advantage of having the cache instead of the disk, right? Get the information off the cache rather than off the physical disk. Well, for waiting to get the information out of the cache, that's not a good thing. So, with the implementation of, late 12.5, the ability to partition the caches minimizes the need to create additional caches, because if we're not getting spin lock contention, there's no reason not to leave everything in default data cache, particularly if you're getting your high cache hit rates. Exceptions might be extremely high volume tables. For example, in a trading system, you might want your securities table to be up there. Find out what you're doing your lookups on when you're doing the lookups on these every single time you do anything. But configuring the cache partitions is very easy to do. And you simply do an sp cache config and specify cache partition equals. Now, I've played with this a lot, and what I have found is that I tend to get my best results by setting the cache partition to something at or higher than the number of Sybase engines that I'm running. So in an 8-engine environment, I'll set cache partition to 8, usually not a problem. In a 10-engine environment, I'll set cache partition to 16. Note that this does have to be a multiple of 2. Most of the spin lock parameters that you adjust on the server are relatively flexible, and usually they're percentages. Address locks. I have, by default, address spin lock ratio is 100. That means one address lock manages 100. One spin lock manages 100 address locks. We drop that down to 25, and suddenly one address lock is managing only. One spin lock is managing only 25 address locks. So if you end up with address lock issues, well, you go and manage the percentages. Here what we're doing is creating additional spin locks. So it's a slightly different approach. Sybase has never been hugely consistent about how they set things up and add or remove things, and this is just one more piece of job security. Note that we can set this up at a global level with the global cache partition number. If, in fact, you want to do this for all your caches, that's probably not a bad approach. As a DBA, I'm a bit of a control freak, so I'm going to be checking all of these manually. but no reason not to set this globally. OEM trips and index trips. This has been a configuration option that nobody has known about, but it's been available since about version 4.8. My own experience goes back to 4.0. My first experience with this one goes back to 4.8, right before we went up to 4.9.2. And what this configuration option does is it says, I want to increase the chances that I can find specific things in cache. So here specifically what we're looking at is pages or OEM entries. What does this mean? Well, I want to keep my index pages in cache. Let's make sure that they don't age out. What an index trip means, or an OEM trip means, is a trip through the cache chain. So we go from the, in our first in, first out queue, we start at the most recently used, we go past the wash marker. What happens if we fall off at the end? Well, at that point, the index page needs to be brought back up into cache if we're accessing it. The idea behind the index trips is to say, what I'm going to do is move it back up to the beginning of the queue and walk it through again. By setting OEM trips or index trips up to 5, 10, 15, 20, we have the ability to keep those index pages in cache. So if you have large index structures and you also have lots of scans going on, what you may want to do is bump these things up and increase your cache hit rates on the index trips. OEM trips, object allocation maps, have to do with how we're going to organize the pages within the individual, physically. Once again, these are things that get hit very hard, particularly as we are allocating pages. So keep that one in mind. Next step, relaxed LRU. You get a small enough amount of data in proportion to the cache size that everything fits into the cache. Sysmon will say, oh, you should try considering plugging relaxed LRU property in here. And how many people here see Sysmon out to the left? A little bit. You almost always see that you should consider changing this one to relaxed LRU relaxed LRU. Has anybody actually ever done that in default data cache? Work out? Okay. Cool. I've seen that in default data cache a lot. I've never had the guts to try that, except for when I knew my default data cache was larger than the databases that I had, and I haven't been in that situation. Nice to hear that that's working out. I've seen that recommendation. I've never put it into place. The idea behind the relaxed LRU is that when we're managing cache, in general, the cache is managed on a first-in, first-out basis. So page starts at the first in, then walks through the page chain, and then falls off the end of the queue. When you know that the objects that you're managing are going to fit into cache, do we really need to keep moving the pages around? If I touch something in the middle of the page chain, so I need to physically move it back to the beginning. The idea behind the relaxed LRU gives you the ability to avoid moving the pages around when you know that they're going to stay in cache anyway. The downside is, if pages need to age out, the cost of aging out the pages is higher, and the chances that you're aging out the correct pages is reduced. So we do not recommend you do this in data cache unless all the data fits in there. If all the data does fit in there, might be an interesting thing to try. I've simply never done it. Glad it has worked out. Next tip. How many people here have gone up to 15? Most of you. When you go up to 15, one of the first things that happens is everybody says increase the size of your procedure cache. There's a good reason for that, because 15 uses a lot more procedure cache than 15 releases. In fact, about 5 months ago, I was at a client site. I was brought in because they had some system crashing going on. They had managed to stumble on a weird Sybase bug that had occurred because the procedure cache size was insufficient, and rather than simply aging something out of cache, what the server was doing was crashing, putting out stack traces and saying, see you later, Charlie. This is a good argument for over-configuring procedure cache, but guess what? If you're over-configuring the procedure cache, that's a lot of memory that's not being used for other things. So, how much space do we set aside for the procedure cache? Well, in the olden days, what we do is we plug in a number like this. We take the maximum number of concurrent processes, we multiply that by something, which should be the